Welcome! We're diving straight into the intersection of cutting-edge technology and regional industry today. In this explainer, we're taking a close look at findings from two really fascinating research reports. They break down the current landscape of industrial design, new tech, and the profound shifts happening right now in Latin American manufacturing. So if you're curious about where the future of creating things is actually headed, you're in exactly the right place.
Let's kick things off with a massive statement straight from our sources. Quote, rapid prototyping technologies are considered the driving forces of the third industrial revolution. Think about that for a second. We aren't just talking about a cool new gadget or, a faster way to make toys. We are talking about a fundamental ground-up shift in how human beings manufacture goods globally. It's an absolute game changer for economies everywhere, and today we're going to break down exactly why that is.
Here's our roadmap for today. We'll start with the third industrial revolution, look at what rapid prototyping actually is, and cover the specific printing methods and tech. After that, we'll dive into transforming design, the SME challenge, and finally wrap up with the regional design future. All right, Section 1, the third industrial revolution. Our source material details how, if we look back at the first industrial revolution, we mostly saw a rigid manual division of tasks. And even as design started to evolve in Latin America, like say the launch of Brazil's very first interior design school, the IADE in Sao Paulo back in 1949, specialized design was still heavily restricted. It was highly manual, customized by master craftsmen, and frankly, almost exclusively available to the elite. But contrast that with our modern era. The third industrial revolution takes that customization and totally democratizes it through rapid prototyping. So instead of slow, painstaking manual labor, we literally have instant digital iteration and global manufacturing capabilities right at our fingertips.
Moving on to Section 2, what exactly is rapid prototyping?
The researchers categorize the processes of rapid design and prototyping into three main buckets. And honestly, they're quite intuitive once you see them laid out. First up, we have subtractive. Imagine a sculptor working with a block of marble, right? The machine literally carves away material from a solid block to reveal the final shape. Second is additive. Now this is what we most commonly associate with 3D printing. The machine builds an object from the ground up, layer by tiny layer. And third, we have compressive, where the technology transforms a liquid or a semi-solid material into a solid shape. Grasping these three approaches is absolutely crucial to unlocking how this tech actually works across different industries.
Section 3, printing methods and tech. Let's look at the actual applications.
First up is SLA, or stereolithography. This one is historically significant because it was the very first patented system for this kind of tech. It originated in the United States alongside the creation of the .stl file format, which you might have heard of. So how does it work? Well, it essentially uses a vat of liquid polymer. When this liquid is hit by ultraviolet light, it instantly solidifies. It's literally like drawing with light to create a solid object right out of a pool of liquid. Pretty wild, right?
Next is SLS, selective laser sintering. What's really interesting here is how different the material is. Instead of liquid, SLS uses powder. A laser beam traces a pattern over a bed of powder, fusing it into a solid. Then, the platform drops down just a fraction of a millimeter, a brand new layer of powder is swept over, and the laser fires again. But the brilliant part? The unfused excess powder actually acts as a built-in support structure for the object as it's being built.
Then we have FDM, fused deposition modeling. Now, if you've ever seen a desktop 3D printer in a school or maybe a local workshop, it was almost certainly an FDM machine. This process feeds a spool of plastic filament into a heated nozzle, kind of like a high-tech hot glue gun. The nozzle melts the plastic and draws out the shape layer by layer, based entirely on a digital CAD file, until your object is fully complete.
Finally, we have LOM, laminated object manufacturing. I love this one because it really shows this sheer variety of materials we can use. See, LOM doesn't use liquid resin or plastic filament. It uses sheets of paper. The machine lays down a sheet of paper with an adhesive backing, heats it up to glue it to the layer below, and then a laser cuts out the exact contour of the object. It just repeats this over and over until you have a dense, solid object made entirely out of stacked glued paper. No way, right? But it works.
Section 4, transforming the design process.
Traditionally, designers have to move through a pretty strict timeline. They start with conceptual prototypes. These are often super fragile, maybe made of foam or cardboard, just to explore basic ideas. Then they move to formal prototypes, to lock in the actual geometric shapes. Finally, they build functional prototypes, which use the real materials to test mechanics and run pilot series. In the old days, getting to that functional stage took an agonizing amount of time and money. Rapid prototyping completely short-circuits this wait.
The crucial shift here is really the business model. The traditional process requires massive initial investments just to create molds and tooling. And because it's so expensive, you kind of have to standardize your product and just hope it sells. But with rapid prototyping, the cost of early error detection absolutely plummets. You find out your design is flawed on day 2, not month 6. Furthermore, because you don't need those expensive molds, you can tweak the digital file for every single customer. It shifts the entire paradigm from slow, expensive, and standardized to incredibly fast, cheap, and deeply personalized.
Section 5. The SMA Challenge. Let's talk about the technological gap.
Now, while this text sounds like a total utopia, the researchers analyzed data from the SME Observatory Foundation in Argentina, and the reality on the ground shows a really striking disparity. In sectors like machinery, electronics, and chemicals, companies are acting as true technological leaders. They're adopting these additive manufacturing tools and really pushing boundaries. However, the vast majority of general, traditional SMEs suffer from what the report calls a massive technological gap. They have low research and development budgets, and honestly, their attitude is often just trying to acquire the bare minimum tech to survive rather than truly innovating. This uneven adoption is a massive hurdle for regional economic growth.
All right, our final section, number 6, Regional Design Future and Latin American Expansion. The sources map out a really encouraging geographical spread of these technologies, which is often spearheaded by academic institutions. In Chile, for example, we saw early adoption with the Andrés Bello University establishing a CAD/CAM modeling lab way back in 2004. That was followed by the University of Chile's Digital Prototyping Lab in 2012. These universities are acting as vital incubators for this third industrial revolution. And we see this expanding outward too. Over in Uruguay, the LabFab MVD was established at the University of the Republic in 2011. Meanwhile, in Argentina, the National Institute of Industrial Technology, or INTI, runs an industrial design research center specifically equipped with a materialization lab. Their goal is to provide rapid prototyping services directly to the industry. These are the grounded regional hubs where the actual knowledge transfer is happening today.
But, and this is a big but, the presence of a few labs just isn't enough. Our sources highlight a pretty stark warning from researcher Hugo Contis regarding the dynamics of Latin America. He notes, quote, "It is predictable that development gaps will tend to deepen if strategies are not defined to improve conditions." Basically, without specific targeted public and private policies to help those struggling traditional SMEs adopt rapid prototyping, the wealthy innovative sectors are just going to accelerate into the future and everyone else will be permanently left behind.
Which leaves us with this final, critical question based on the reports. Will regional industries across Latin America successfully integrate public policy with design and science to adapt to the third industrial revolution, or will that technological gap permanently widen, leaving local manufacturing entirely in the dust of the global market? It's a complex challenge for sure, but understanding the technology and the data, just like we've done today, is absolutely the first crucial step. Thanks for joining me on this explainer. Keep asking questions, and I'll catch you next time.